Hey guys, we're going to solve some systems by substitution. This is typically used as a little bit of a review in an Algebra 2 class, so I'm going to go a little bit quick here. So solving systems by substitution. Whenever I look at a system of equations, anytime I get, say, a y equals something or x equals something, just one of the variables isolated, that usually tells me right away, we're going to do this by substitution. So how it works is I know y is equal to 3x minus 4. Y is equal to 3x minus 4. So anytime I see y, I can put 3x minus 4. So the reason it's called substitution is I'm going to substitute in for this y here. So what I'm going to do is I'm going to go from a system of two equations, two variables, and by substitution, I'm going to get it down to one equation, one variable. So by substitution, I'm going to go from two equations, two variables, down to one equation, one variable. When you just have a plain old y equals like 3x minus 4, you can't solve for x or y there. We can't find the exact value. So what we're going to do is we're going to get down to one equation, one variable. That is something we can solve using basic algebra. So by doing substitution, we get to this point, and we could solve and we could find the specific values for x and y. So what I'm going to do is I'm going to rewrite this second equation, but anytime I see y, I'm going to put in parentheses and substitute in 3x minus 4. So here we go. I'm going to have 4x plus 3. Again, instead of writing y, I'm going to put parentheses 3x minus 4 equals 1. So I just replaced only the y in the second equation. So I just have to solve this equation. We've now to one big equation, one variable x. I only see x now, so I can solve this using basic algebra skills. To do this, first thing I'm going to do is let's distribute that 3 through. So the 4x is going to stay the same. 3 times 3x is 9x. 3 times negative 4 is negative 12. And this is equal to 1. Combining like terms, 4x plus 9x is 13x. Still have a minus 12 there is equal to 1. Solving from there, we want to isolate the x, so let's add 12 over. I have 13x equals 13. Divide that 13 over, and we have x equals 1. Now, I've gotten down to that one equation, one variable, but the goal, again, is to find both variables. So I need to go back up to the two equation, two variable part and figure out my other variable. So what I'm going to do is I could use either of the two equations. I'm going to plug that x equals 1 from the bottom into either of these two equations. I'm going to use the top one. So anytime I see x, I'm going to put a 1. So I'm going to have y equals 3 times 1 minus 4. So I have 3 minus 4. Y equals negative 1. So I have solved my system. That's all it takes. Substitution goes a lot faster if you've seen this in comparison to elimination. It goes a lot quicker. But again, you kind of need some special case of it set up in order to do so. Before I end this, things that you need to be careful of. There are some special cases you need to be careful of. So things that can happen is, say when you're doing your substitution, you combine your like terms and all of a sudden you end up with, say, 0 equals 7. What this means is you did not screw up, but 0 never, never, ever equals 7. This is a case where your answer is no solution. Let's say you plug in, you combine like terms, and you end up with a case of like 12 equals 12. Well, is 12 equal to 12? Yes, it is. It's always equal to 12. 12 is always equal to 12. This is a case where you might run into, well, you are going to run into infinite solutions. So do be careful of those two cases. Kind of what's going on there, so you can kind of visually see this, is when you have a system of equations and you're solving it, you're really looking at two lines and you're finding out where they intersect. So these two lines intersect at the coordinate 1, negative 1. So down here, when you have this case come up and it's a no solution, All that means is the two lines are parallel. They're never ever going to intersect. That's why it's no solution. What it means for the infinite solutions is you have a line. That's one of your equations. Your other equation is actually the exact same line. So they intersect everywhere, and hence infinite solutions. Anywho, that was solving systems by substitution.